In this problem, I'm asked to find all the missing sides and angles of this triangle. So the first thing I need to figure out is, am I going to use the law of sines or the law of cosines? Since I have a side and the angle across from it, that's a perfect example of a way to use the law of sines. So I'm going to start by setting up my first ratio. I could do 28 over sine 39. I could also flip this and do sine 39 over 28 if I wanted to. And since I know 41, then I can find the angle across from it, so I'm going to solve for sine r. Now I'm going to cross multiply, which gives me 28 times sine r equals 41 times sine 39. I'm not going to put this in my calculator until I'm completely done. So now I'm going to divide by 28 on both sides. And so at this point, I'm going to go ahead and put everything on the right-hand side of my calculator. This gives me approximately 0.92. So that's not my answer because my variable is still trapped inside of the sine function. So now I need to use inverse sine of 0.92. So when I put that in my calculator, I'm doing second sine, and then I'm actually keeping my exact answer. So I'm not typing 0.92. And I get approximately 67.1 degrees for angle R. Now that I have two angles of the triangle, I can quickly find the third by adding them together and then subtracting the sum from 180. So this gives me 106.1. And that means that my third angle is 73.9 degrees. So now I have all my angles, I have two sides. Now that I have all my angles and two sides, I need to just find my third side. So I can use a combination of things. I can use still 28 and sine 39 as the ratio that I know. And now since I need to solve for the side across from angle P, I'm going to use that over sine 73.9. Again, I'm going to cross multiply and divide. So I end up with 28 times sine 73.9 over sine 39. And like before, I'm going to put that all into my calculator at once. To the nearest tenth, I get that P is 42.5. So I've used the law of sines to find all of the missing pieces of this triangle.